Good morning, one and all physics students, and welcome to another episode of Physics. It's Mr. Finn coming at you from neighborly Northville. Hey guys, just got a couple things today. I want to introduce you to something called the pendulum. We're going to be starting a unit on waves here, obviously, as we've been going through the end of electricity and magnetism. But before I do that, I want to get you guys to maybe just understand that in the next few weeks, some of these videos are previously recorded for the honors class. Okay, you don't have to worry about some of the in-depth study that we go through for the honors classes, but the general concepts, those should be the same. So, if you're following along in your Hewitt textbook and you come across stuff that's just not in there, don't worry about it. Work on concept only. So some of the things in terms of calculations will not be there for you guys, but obviously it was there when I recorded for the honors group. And of course, if I start talking about questions on the video from the honors group, you don't have to worry about those either, because those questions largely came from stuff that they're doing in their textbook, which is different than what you're doing in yours. So pay attention only for the concepts as they go through, and a lot of that stuff is very applicable to what we're doing. But remember, you guys have this as a resource. So that is what we'll be focusing on for you guys. Okay, that being said, we need to take a look at our pendulum here. So I'm going to turn the video around so we can see it a little bit clearer. And I'm going to do just a couple things with the pendulum to get you guys on track with waves. Hey guys, I'm here with my pendulum and my phone, which I'm going to use as a stopwatch. Got 0 time on there. Now, for a pendulum, you can make a pendulum out of anything you want. I just have a rubber or a metal washer on the end of a string, and it's tied up here to this, looks like a fireplace tool holder. But any pendulum exhibits wave characteristics, and that if you displace it and let it go, it simply moves back and forth. So this creates a wave pattern, and you're going to see that when you see the Tom Altman video at the Science Exploratorium. But this wave pattern back and forth obviously is a function of the tools, of the segments, the properties of the pendulum. So if I want to displace a couple of things, what I'm going to do is I'm going to displace here. So that's not very far, maybe a few centimeters or a few inches from its equilibrium point. And I'm going to time 10 oscillations. 10 oscillations. That means back and forth. That's one oscillation. Mark, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 14.79 seconds. Okay guys, so what I want to try and do is I'm going to do the same thing, but I'm going to make the amplitude of the swing much bigger. The amplitude is going to be the size of the displacement. Okay, here we go. Mark, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 14.91 seconds. That looks just about the same. We're only off by like 0.2 seconds for 10 oscillations. Now remember, as you guys looking forward to some of the wave stuff, we can find a period, the time it takes for one oscillation, by just dividing my total time by the number of oscillations I did, 10. I'll have you guys do that in the lab this week. Now, what I'm going to do is just wrap it around here a little bit and shorten my pendulum. So all I've done is just wrap the string around the holder part, and I've shortened the length of the pendulum. Let's do it again, displacing for 10 oscillations. Arc, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11.95 seconds. Now what I'm hoping you guys saw was a little bit of the idea behind a pendulum and waves. Changing the amplitude of the swing for this pendulum didn't result in much change, if any. Changing the length of the pendulum was a major change, somewhere between that 17 seconds and like 13 or 14 or 12 seconds for 10 oscillations. More importantly, guys, though, a pendulum is a good example of a wave study. Simply back and forth. It's a repeatable event. It's a harmonic motion, simple harmonic motion to be exact. So if I start here, there's a restorative force that will allow this pendulum to move this way. As it moves through its equilibrium point, it's got a lot of velocity and not much potential energy anymore. So all its energy is kinetic. And then, of course, it slows down and puts energy back into potential again. So we can still think about this in terms of the energy that we had before. But this is a great example of what we can do to study waves. And we'll be doing more of that, but as you guys get into the video on Tom Altman and the Science Exploratorium, I want you to keep in mind what our little demonstration here with the pendulum was all about today. All right, let's wrap up and get you started. Okay, guys, there's lots of ways we can study waves. A pendulum is just an easy way to start to see a back and forth motion that we can use, called a wave length. When this pendulum goes from start all the way over to its opposite point and then back again, that's one wave cycle. And that cycle repeats itself over and over again. And you can see, playing around with the pendulum a little bit, we can determine some of the things about it that apply to waves. Moving forward, guys, you guys are going to have some, again, like I said, previously recorded videos. But don't be bummed out or don't be discouraged. Some of this stuff is a little bit more in-depth due to the honors video creation. Just get the basic concepts and move forward with the questions you have in your Hewitt text. And I'll be around to help. Okay, guys, why don't you get started with wave stuff today, and we'll get the Google form up a little bit later today.